All right, so we're going to talk about adding and subtracting scientific notation. So adding, subtracting scientific notation when the exponents are the same is pretty simple. You just add or subtract the coefficients. So for example, if we have, say, 5.0 times 10 to the second, I'm just going to parentheses so it's easier to see, minus, say, 2.0 times 10 to the second. This is one of the easier problems because the exponents are the same, so what you just do is you would subtract the coefficients. So the numbers before are called the coefficients. And so 5 minus 2 is just 3.0. Remember, this goes to a tenth. This goes to a tenth when you're subtracting. You should go to the tenth according to the sig fig rules, times 10 to the second. So you just keep the, you would keep the exponent the same. All right, and so the same, if, like, let's say I just change this to a plus, so 5 plus 2 is 7.0 times 10 to the second. Okay? So that generally is kind of a simple, but it gets a little more difficult. Say, for example, let's just do the same example. But let's say now the exponents no longer match. So let me get this out of the way. So this is kind of a two-step problem. What you have to do is you have to convert either this or this into the same exponent. So like you have two choices. You can convert this one into 10 to the first, or you can convert this one 10 to the second. My suggestion is I found it easier to take the smaller, so this is the smaller exponent, and convert it to the larger exponent. So if I take 2.0, so let's just do our first step of the problem. If I take 2.0 times 10 to the first, if I want to bring that to the 10 to the second, that would be, so what I'm essentially doing is I'm raising this up one, right? And so to do that, I have to kind of lower this. So if this side goes up, let me do this in a different color. So I'm raising this side up by one, then I have to move the decimal smaller. It's almost like a balancing out. So 2.0 times 10 to the first equals this here. 0.2 times 10 to the second. This is 5.0 times 10 to the second. So now I have it where they're both the same exponents. 5 and 0.2 is just 5.2 times 10 to the second, right? If I added the two together. All right, so when the exponents don't match, when you're adding or subtracting, you have to change, or you have to convert it so that you have the same exponents, and then you can add normally or subtract normally. Okay, and so that's the only extra step you'll have to do. So let's just do some practice problems here. So here we notice that the exponents are the same. So 2 plus 3 is going to be 5, right, times 10 to the third. Here 5.0 minus 2.0 is going to be 3.0 times 10 to the negative second. And this is where it gets a little trickier, right? So I have 6.00 times 10 to the fifth, 2.00 times 10 to the fourth. What you'll notice is the exponents don't match. So I'm going to take this and convert it. And so this will become 0.20 times 10 to the fifth. If I add the two together, 6.00 plus 0.20 is 6.2 times 10 to the fifth power. Let me just talk quickly about sig figs. So if you look here, this is 6.00, right? So 6.00, and this is 2.0, right? So initially, this goes out to the hundredths place, and this goes out to the tenths place. So before I convert, I actually look at the sig figs. So if I have the hundredths place and the tenths place, the least precise place is this tenth. So I'm going to round to the tenths place. So that's why I chose to round it to 6.2. All right. And then taking a look at this one, so this one's interesting. So I have 7.0 times 10 to the third minus 6.0 times 10 to the negative 1. Remember, I usually take the smaller exponent and then I move it up. So this is going to be a little tricky because I'm going to go from negative 1 to 3. So as I convert this, I want something times 10 to the 3, right? Now, to go from 10 to the negative 1 to 10 to the third, what I'm essentially doing is I'm increasing the exponent by a power of 4, which means on the other side, on the coefficient side, I have to decrease it by 4 because I have to have the same, they have to have equivalent. So if I increase one side by 4, I have to decrease the other by 4. So what I'm going to do is I'm going to take that 6.0 and move the decimal 1, 2, 3, 4. So ultimately, I'll get, if I like actually fill this in, 0 point, and then so 1, 2, 3, 0, 0, 0, 6, 0 times 10 to the third. All right? So let me recap. So I have 7.0 times 10 to the third minus 0.00060 times 10 to the third. So if you do this, like if you actually calculate it, you'll get like 6.9994 times 10 to the third. This is where it gets a little, so I've done it mathematically, right? But then let me go back and take a look at my sig figs. If you look, now this is subtraction. So remember, in addition to subtraction, when you're doing sig figs, we have to look at the last significant digit, the estimated digit. So this goes to the 10th, this goes to the 10th. So I'm going to round to the 10th, which is right here. If I round to the 10th, it's 7.0 times 10 to the third. So what you essentially did is you took this big number and you subtracted a really small number from it, right? Is really what you did. And ultimately, that number is so small that it doesn't matter. Like it didn't play a significant role. Let me rewrite that. So because it looks like so 7.0 times 10 to the third minus 0.0 ended up being 6.9994 times 10 to the third. I have to look at sig figs. Now, remember sig figs, when you're subtracting or addition, you look at the place values. So the last place value is the 10th. This is the 10th. And so, therefore, we're going to round to the 10th. So this is a 9, but the next number is a 9, right? So 6.9 will round up to 7.0 times 10 to the third is your answer. Okay. All right. There's more practice as well here on the next slide.